All right, this is part 2 of the refraction video. I have some array diagrams here. So the first one looks like we're going from something that's less dense to more dense. So now keep in mind that in the previous video, I said that n sine theta remains constant because ni sine theta I equals nr sine theta r. So this remains constant. So basically, the n is inversely proportional to the angle. Okay, so if we're going from less dense to more dense, it means n goes up, so the angle has to go down. Okay? Okay, or you can also look at it as like you're slowing down here. In here, you're going from more dense to less dense, so n drops, so the angle has to get bigger. So instead of going straight like that, you bend away from the normal. And everything has to be done with respect to the normal. Okay, let's look at this ranking task 3. Okay. So here, if we shine a ray of light, it's going to go this way. It's going to hit the wall here. Okay. Now, so we want to know if the shadow, so basically this whole section here is the shadow. So let's call that height h. Okay. If we put a piece of glass in there, will the shadow be lower or higher? Well, let's trace it and see what happens. So now we're going to come in with the light from here. We're going to hit the glass. Now here's the normal to the glass. Okay? Now we're going to bend closer to the normal because we're going from air to something that's more dense. So the bending will be like this. I'm exaggerating this, right? And then when we get out, so now keep in mind that we already dropped. When we get out, we'll go out parallel to the original one, right? But never at that height here. So this height, h2, I guess, has to be less than h. So the shadow will be less because of that drop, that bending. Okay? And even if you bend back out again, you will never recover that, what you lost, because you're bending back at the same angle. Okay. All right. If the entire arrangement from case B were put in water instead, the height, the new height will increase with respect to this height, because in water, the difference in the indexes of refraction between glass and water are much closer than between glass and air. So you're not going to have a lot of bending. So there will be less bending, which means you're not going to drop as much as when you're going from air to glass. So the height of the shadow should increase. I think that's what I have here. Yeah. Okay. Let's look at RT4. Now this probably has to do more with the next video, which is the total internal reflection, but I can talk about it now. Now, we know that this n sine theta, right, remains constant. Okay. Now, the case where this theta reaches 90 first will have a lower n. Okay? I hope you can see that. So if you reach 90 first, your n is smaller because you bend in more, in other words. Okay? Now, in this case here, for case A, you already passed the 90. Okay? So your angle is already greater than the critical angle, what we call the critical angle. So here we reach 90 earlier, right? Which means in this case here, the n is less. Okay? So n for A is less than the n for B. Okay? So the index of refraction for case B is bigger. And I hope you can see that, because it all depends on which one sees its theta increase faster. This one, it's still not at 90. This one is already reached 90 and passed it. Okay. Is the speed of light in oil greater in case B? Well, let's see. The n so n is C over V. Okay? So if the n is, okay, so we have to figure, so if you want to have a high speed, you have to have a low n. So it's going to be greater in case A, because they are inversely related. Okay, let's look at the next one, RT5. Okay, so red light bends less than blue light, which means it has a smaller index of refraction. Okay, so if n for red is smaller than for blue light, okay, it means that the V for red is higher than the V for the blue light. Okay, I mean the difference is extremely small. Okay, which means it will take less time for the red light, red laser to make it to the other side. Okay, because V and time are inversely proportional. So if a large time will result in a large speed will result in a smaller time. Okay, number 9. Okay, so if you're going from air to water, so let's say you shine in a red light from air into the water, the light will still look red inside the water. So, and the color of light is a characteristic, the frequency is decided by the color of the light. So red light is red because it has a unique frequency, so it's the frequency. So what's going to happen to the speed will drop, and we know that V equals lambda times frequency because light behaves as a wave. So if this F stays constant, if the V drops because you go into a denser medium, the lambda will get shorter. Okay. And the amplitude has to change because you're kind of like interacting with the water. Okay. The index of refraction of a type of glass is, and the index of refraction water is. So you're going from glass to water. So you're going from more dense to less dense. So the N drops, which means the angle has to get greater. Okay. Light goes from a material having a refractive index of N1 into a material of, okay. If the refractive light is bent away, okay, so if it's bent away, it means N2 is smaller than N1. If it's bent away, it means the angle is bigger, which means the N is smaller. So the answer should be A. Okay, let's look at number 12. A beam of light traveling in air strikes a plate of transparent material at an angle of 56. It observed that the reflected and refracted beams form a 90-degree angle. So let's try that. So it looks like this. Coming with 56, I'm going to reflect with 56. You're always going to have some reflection. And you're coming from air and you're hitting some other material. So instead of continuing straight, you're going to bend. Okay? And it's telling me that this angle here is 90. So if I want to find the index of refraction, I have to do, coming from air, 1 sine of 56 equals N for this new material, sine of this angle here. So I think I can figure out that angle. So if this is 90 and that's 56, this will complement the 56 so that the whole thing becomes 180. So that looks like it's 34. And if you do the math here, you should get, just make sure you're in degree mode. You should get 1.48. Okay. Okay, a light ray in air strikes a glass plate whose index of refraction is 1.42. Some of the light reflects off the surface, but most of it enters the glass. If light, okay. All right. So this one looks like this. So you come in with an angle, and then you're going to bend. Okay, and this angle here is half of that, which means the index of refraction here is bigger, right? It's because you're coming from air to glass, which makes sense. So they're asking me to find the angle of refraction. It's asking me to find this angle. But they're also telling me that this angle is half of this angle. So this is 2 theta basically. And this is 2 theta also. So I can do 1 sine of 2 theta equals n sine of theta. Now, how do we solve this? You have to rely on your trig identities basically. Double angle formula. So that's 2 sine theta cosine theta equals n sine theta. Can divide by sine theta. And if you solve this equation here, this is 1.42. You can plug that in, I guess. And we should get an angle of about 44.77, so about 45 degrees. Okay. A light ray in glass arrives at the glass surface. I guess this is phi. This is 61, and this is 48. Yeah. Okay, so this is 1.33. Okay. Don't assume that the index of refraction is about 1.5. So you have to find it first. Okay. So we don't know what n is here. The angle of incidence is now changed to 25. What's the new angle of refraction? So I think we can find the n first, right? And then redo the problem with the angle of incidence as being 25, because I think we have enough information to find n. Or we don't need to find the n. We can write it like this. 1.33 sine 48 equals n sine of 61. So this is what I was saying. Like you find n, and you redo the problem by making this angle 25 and finding this new angle. Or you can be lazy like me and do this. 1.33 sine of 25, I'm writing it for the other case, is n sine of theta, or phi basically. Okay? So now what I'm going to do, I'm going to divide in this direction. So it looks like it's sine 25 over sine of 48 equals, see the n's are gone, becomes sine of phi over sine of 61. And you can solve that equation. Okay, and that should do it for this video here.